You know, we all think of a day as this fixed thing, right? 24 hours, solid. But what if I told you that that fundamental unit of time is actually changing? That the Earth's day is, in a very real sense, expanding? Let's dive into what that really means.
So this whole thing kicked off when I saw this headline. And just look at the language here. A looming threat. The Earth is stopping, and we'll have 25-hour days soon. I mean, wow. It's totally designed to grab you, maybe even make you a little nervous.
And really, it all comes down to that one little word, soon, because that word is the key to this whole story. In planetary science, the definition of soon can be, well, mind-bogglingly different from our own. So what's the actual science behind all this?
To figure that out, we have to understand why the Earth is slowing down in the first place. And the culprit, or maybe I should say, the dance partner, in this whole cosmic ballet is our very own moon.
The sciencey term for this is tidal friction. And honestly, it's pretty much what it sounds like. The moon's gravity is constantly pulling on Earth's oceans, creating this drag that acts like a perpetual, super gentle brake on our planet's spin.
Okay, so here's how it works, in 3 simple steps. First, the moon's gravity pulls our oceans into a bulge. Second, our planet actually spins faster than the moon orbits it, so the Earth is always rotating underneath this big watery bulge. And third, all that movement creates friction, a drag, that over immense timescales slows our rotation down bit by bit.
The easiest way to think about it is like this. Picture the Earth as a spinning top. The moon's gravity is kind of like a hand just gently brushing against it. It's not enough to stop it, of course, but just enough to bleed off a teeny tiny bit of speed with every single rotation.
All right, so we've got the physics down. Now let's get back to that really crucial question that headline brought up with its use of the word soon.
This is where we have to switch our brains from thinking in human time to thinking in geologic time. Our soon might mean, next week. The planet's soon is an entirely different beast.
Okay, so we start with today. We all know it. It's our familiar 24-hour day.
And the headline's destination? A future Earth with a 25-hour day.
So, the big question is, what's the actual travel time between our 24-hour day and that future 25-hour day? Just how soon is soon?
The answer? It's roughly 200 million years. Yeah, so not next Tuesday. That single number just completely changes the entire story, doesn't it? This isn't some looming threat. It's just a fascinating planetary process.
And to really put that number into perspective, think about this. The age of dinosaurs began more than 200 million years ago. All of recorded human history, all of it, is just an invisible little sliver on this timeline. Our definition of soon just doesn't even apply on this scale.
So, if this change is so unbelievably slow, does it even affect us at all? Well, yes, actually, it does, in a very subtle, super high-tech way that you've probably never even thought about.
The solution is something called a leap second. Every so often, the world's official timekeepers literally add a single second to our clocks. It's this tiny little correction to keep our perfect digital time in sync with our imperfectly slowing planet.
So why do these even exist? Well, it's kind of funny. Our atomic clocks are almost perfectly precise. They're just too good. The Earth, on the other hand, is not a perfect clock. It wobbles, and as we've seen, it's slowing down. Over time, that tiny mismatch adds up, and a leap second is basically us hitting the pause button for just a moment to let the Earth catch up. And that 1-second sync is absolutely critical for things that rely on perfect timing, like GPS, satellites, and even the global financial markets.
Okay, so let's circle all the way back to where we started, with that alarming headline. And let's put it in its proper place once and for all.
On one side, you have the claim, a looming threat happening soon. And on the other, you have the reality, a natural, impossibly slow dance between the Earth and the Moon that's been happening for billions of years and will continue for billions more.
So, let's just recap the key takeaways here. Yes, the Earth's rotation is slowing down, and it's thanks to the tidal friction from the Moon. But that 25-hour day is about 200 million years in the future. So this isn't a threat we need to worry about. It's really just a chance to appreciate physics on a truly cosmic scale.
So I'll leave you with this question to chew on. When we learn about a process like this, are we really seeing a threat, or are we just getting a chance to hear the quiet, steady ticking of a cosmic clock that measures time in eons? In the end, it really all just comes down to perspective. Thanks for joining me on this explainer.